Dinosaurs. These magnificent creatures once ruled our planet. They ignite our imaginations with their size, power, and ferocity. Among them, Tyrannosaurus rex reigns supreme, a king among dinosaurs. But what if I told you that T-Rex wasn't alone? New evidence suggests a royal family of tyrannosaurs may have walked the earth. Prepare yourself to meet T. regina and T. imperator. These newly proposed species challenge our understanding of the tyrant lizard king. They offer a glimpse into a more complex and diverse dinosaur world than we ever imagined. This is a story of scientific discovery, debate, and the ever-evolving nature of our knowledge. It's about challenging the known and embracing the unknown. It's about a royal family that has been silent for millions of years, finally ready to reveal their secrets. The story begins, as many paleontological discoveries do, with fossils. Scientists have been unearthing Tyrannosaurus bones for over a century. However, recent analysis of these bones has revealed intriguing variations. These differences, once dismissed as individual quirks, have sparked a heated debate. At the heart of the controversy lies the question of species. How do we classify animals separated by millions of years? How much variation is too much within a single species? These are not easy questions to answer, even with the advanced tools of modern science. The researchers proposing the new species point to key differences in femur robustness, dental structures, and the geological layers in which the fossils were found. These variations, they argue, are significant enough to warrant recognizing multiple species within the Tyrannosaurus genus. The femur, or thigh bone, is a critical piece of evidence in this paleontological puzzle. Some Tyrannosaurus femurs are robust and sturdy, while others are more slender and graceful. This difference in bone structure, known as femur robustness, is more than just an anatomical curiosity. It hints at different ecological roles and evolutionary pressures. The robust femurs suggest a powerful build, capable of withstanding the stresses of tackling large prey. The more slender femurs, on the other hand, point to a swifter, more agile predator. These differences in locomotion could reflect adaptations to different hunting strategies or environments. Could these variations in femur robustness be attributed to individual differences within a single species? Perhaps. But the researchers proposing the new species argue that the differences are consistent and pronounced enough to suggest distinct species. Teeth, those sharp instruments of survival, also hold clues to the Tyrannosaurus family tree. While all Tyrannosaurus teeth were formidable weapons, subtle differences in their number and shape have caught the attention of scientists. Specifically, the number of incisiform teeth, the small teeth at the front of the jaw, varies among specimens. Some Tyrannosaurus skulls possess 4 incisiform teeth, while others have only 2. This seemingly minor difference in dental configuration could reflect variations in feeding behavior or prey preference. The number of incisiform teeth might have influenced how the animals tore into their prey, potentially leading to specialization in hunting certain dinosaurs. The combination of femur robustness and dental variations paints a compelling picture of diversity within the Tyrannosaurus genus. These anatomical differences, when considered alongside the geological context of the fossils, strengthen the case for multiple Tyrannosaurus species. Section 5. Layers of Time. A Geological Perspective. Time, as it is wont to do, complicates matters. The passage of millions of years has left its mark on the Earth's crust, creating a complex tapestry of rock layers and fossil records. The fossils of these Tyrannosaurus specimens are not found randomly scattered throughout the rock layers. Instead, they are meticulously organized, each layer telling a different part of the story. They are organized in a specific temporal sequence with different forms appearing in distinct geological layers. This organization is key to understanding the timeline of their existence. This stratification is crucial to understanding the evolution of Tyrannosaurus. Each layer provides a snapshot of a different era, revealing how these creatures adapted over time. The oldest Tyrannosaurus fossils, those with the most robust builds and 4 incisiform teeth, are found in lower rock layers. These early specimens give us insight into the origins of the species. As we move up through the layers, we encounter fossils with more slender builds and 2 incisiform teeth. This change in morphology indicates a significant evolutionary shift. This progression suggests a gradual transition over time, with each species potentially occupying a distinct ecological niche. The changes in their physical structure reflect adaptations to their environment. The geological context of the fossils adds another layer of complexity to the debate. It provides clues about the environment in which these creatures lived, and how it influenced their development. It suggests that these variations are not random but rather reflect a pattern of evolutionary change over time. The distribution of fossils across different layers supports this theory. This temporal separation strengthens the argument for recognizing multiple Tyrannosaurus species. Each species represents a unique chapter in the evolutionary history of these magnificent creatures. Section 6. Meet the Royals, T-Rex, T. regina, and T. imperator. Let's meet the proposed members of this Tyrannosaurus dynasty, a fascinating trio that has captured the imagination of paleontologists and dinosaur enthusiasts alike. First, we have the reigning monarch, Tyrannosaurus rex, the most famous and well-studied of the group. This iconic species retains its crown, but its reign is now shared with other members of its royal family. T-Rex, as we know it, possessed a robust build, 2 incisiform teeth, and roamed North America during the late Cretaceous period, making it a dominant predator of its time. Next, we have the elegant and agile Tyrannosaurus regina, the queen, who brings a different set of traits to the table. This species is characterized by its more gracile build, slender femurs, and 2 incisiform teeth, suggesting a lighter and more agile frame. T. regina likely relied on speed and agility to hunt its prey, potentially occupying a different ecological niche than its more robust relative, T. rex. Finally, we have the mighty Tyrannosaurus imperator, the emperor, who stands as a testament to the early days of this lineage. This formidable predator is the oldest of the 3, characterized by its robust build, 4 incisiform teeth, and its presence in lower geological layers, indicating its ancient origins. T. imperator likely laid the foundation for the Tyrannosaurus lineage, paving the way for its descendants to evolve and diversify. These 3 species, if validated by further research, represent a fascinating diversification of the Tyrannosaurus lineage, showcasing the evolutionary adaptability of these magnificent creatures. They offer a glimpse into a world where multiple Tyrannosaurus species coexisted, each with its unique adaptations and ecological role, painting a richer picture of the prehistoric past. Section 7. The dissenters' roar, doubts and debates. The proposal to split Tyrannosaurus into multiple species has not been met with universal acclaim. The scientific community, as it should, has responded with healthy skepticism and rigorous debate. Some paleontologists argue that the observed variations in femur robustness and dental structures could simply be due to individual differences within a single species. They point out that sample sizes are relatively small, and the fossil record, while improving, is still incomplete. They argue that more evidence is needed to confidently establish distinct species. Furthermore, they suggest that variations in bone structure could be influenced by factors like age, sex, or individual variation within a population. This debate highlights the challenges of interpreting the fossil record and classifying extinct animals. It's a reminder that science is an ongoing process of discovery and refinement, where new evidence can challenge existing paradigms and lead to revised understandings. Section 8. A Paradigm Shift, Rethinking Tyrannosaur Evolution. Despite the ongoing debate, the possibility of multiple Tyrannosaurus species has significant implications for our understanding of dinosaur evolution. It challenges the long-held notion of T-Rex as the sole apex predator of its time, suggesting a more complex and dynamic ecosystem. If multiple Tyrannosaurus species coexisted, how did they share resources and territory? Did they compete directly, or did they evolve specialized hunting strategies to minimize competition? These questions open up exciting new avenues of research into dinosaur behavior, ecology, and evolution. The recognition of multiple Tyrannosaurus species would also require us to reevaluate the evolutionary relationships within the Tyrannosauridae family. It could shed light on the factors that drove the diversification of these fearsome predators and their rise to dominance during the late Cretaceous. Section 9. The Future of the Tyrannosaurus Trio. The debate surrounding the Tyrannosaurus trio is far from over. Scientists and researchers continue to delve into the mysteries of these ancient giants, seeking to understand their true nature. More research, larger sample sizes, and further analysis of existing fossils are needed to confirm or refute the proposed species. Each new discovery brings us a step closer to unraveling the secrets of the past. The discovery of new fossils, especially those with well-preserved skulls and skeletons, would be invaluable in resolving this paleontological puzzle. These finds could provide critical evidence to support or challenge current theories. However, regardless of the outcome of this debate, one thing is clear. The Tyrannosaurus genus is far more complex and fascinating than we once thought. The intricate details of their lives continue to captivate our imaginations. The possibility of multiple species coexisting and evolving alongside each other adds a new layer of intrigue to these already captivating creatures. It paints a picture of a dynamic and ever-changing prehistoric world. The Tyrannosaurus trio, whether they retain their royal titles or are ultimately unified under a single banner, reminds us that the world of dinosaurs is full of mysteries waiting to be unearthed. Each fossil is a piece of a grand puzzle. It's a world that continues to surprise and challenge our understanding of life on Earth, reminding us that the past is not set in stone but rather a story still being written. Every discovery adds a new chapter to this ongoing saga.